Good day, folks. Welcome to my YouTube channel. This is a question on momentum. Let's cut the chase. Guys, those who are new here, welcome. Don't forget to subscribe, liking my videos, and don't forget to subscribe. Guys, it's about 60% of you watching my videos without subscribing. Please, guys, do the right thing. It costs nothing to subscribe to support your channel. My channel. Thank you so much. Let's cut the chase. It says a truck A with a mass of 2000 kg moving eastwards and collide with a truck B of mass of 1500 kg. The graph is not drawn to scale. Show the momentum of each of the truck varies with the same time. Here's a truck. I'm a very good drawer, you guys. One thing about me. And here's a car. Right, and this is truck A and this is truck B. It's two trucks, in fact. It's not a car. I don't know where I'm getting that. So they're going in opposite direction, right? The other truck is smaller than the other, but they look like the same. It matters not. All right, now it says they're moving eastwards and collide. So this one is moving east, guys. When we talk about the east, we're talking about the east, that side, and the west. So they collide, guys. So it's a head-on collision, right? How do I see it's a head-on collision? Here's the initial direction of the truck A. Truck A was going to the east, so above the x-axis is going to be our east, so we'll choose east as what? As positive, right? So this is the initial momentum of the truck, and then after it traveled at 0.2 seconds, it collided with truck B, right? At the same time, they had their initial velocity. So this is the initial momentum of truck B. It's going in this direction, right? This is going in this direction and this is going in this direction. You can see from the graph they had different momentum, initial momentum and initial momentum. So this will be the initial momentum and this will be the final the initial momentum, both, right? And then they collide after 0.2 seconds, and then this is their change in momentum. The momentum of truck A, it changes to 1, right, from 6. And guys, if you look here, this is 10 times 10 to the power 3. It's 10 to the power 3, so this is going to be 6 times 10 to the power 3, right? It collided with the momentum of 6 to the momentum of what? 1, which is this is the final momentum of what? Of A, right? And B, the initial momentum were not given there, but we know there was a change in momentum. After it collided, it went in opposite direction, so B collided and went in that direction. So it's gonna be like this. After collision, this is B, it's gonna go in that direction. So it was going in the westerly direction, now it's going in an easterly direction. Guys, this is east and this is west. And then truck A, and truck A, let's see it's going in which direction. Truck A, when we see here the momentum change in the same direction, there's a decrease in momentum, so it's still going in that direction. So they collided, but they're not moving off together, but they're going in the same direction after. This is before and this is after, right? Okay, let's move fast a bit. And then their contact time, it's from 0.2 to 0.3. That's the contact time there, guys. I hope I make sense. Truck B went in different direction. It was going in the easterly direction before collision, and then it collided, and then it went in opposite direction after collision. And truck A, it collided with truck B, and it still continued in the same direction, but with the lower momentum. Now 4.1, it says write down the principle of conservation of momentum, exam guideline. 4.2, it says write down the initial momentum of track A. So the initial momentum of track A, guys, here's track A here. The initial momentum of track A is that, so it's going to be 6 times 10 to the power 3 kg meter per second. Right, that's the initial momentum of track A, right? So let's cut the chase and go to 4.3. It says determine the magnitude and direction of the velocity of track B before collision. So we want this momentum right here, right? So this momentum we can only get by using the principle of conservation of momentum. Guys, when we write a vector in 4.2, this says the momentum is going in which direction here? It's going in the easterly direction. So this is, we want the momentum here of car A is going in the easterly direction. Now when we say determine the magnitude and direction of the velocity of track B, what we're going to do there, we are going to use the principle of conservation of momentum. 4.3 will say the total momentum before it's equal to the total momentum after, right? Now we have the momentum of car A, track A. We don't have the momentum of track B, but we want the initial velocity there, and we don't even have the momentum there, but we have the masses. So it's 2000 and 1.5 for B, right? So what we're going to do, we're going to say initial momentum of what? Of A plus the momentum of B. So since we are writing this here because we're given the momentum, so here we want the velocity, so it's going to be mass of car B times by the initial velocity of car B, and then the momentum after, we have the momentum after of A plus the momentum after of track B, right? So the momentum of track A is 6. Is 6 times 10 to the power 3 plus the mass of B, we're told it's 1,500, right? It's 1,500, so it's going to be 1,500, and the velocity is the one that we're looking for, equal to the momentum of car A, the final momentum of track A, the final momentum of track A, it's 1. So it's going to be 1 times 10 to the power 3 plus, and the final momentum of track B, this is the final momentum. This is the final momentum of B. It's 2. So it's 2 times 10 to the power 3, right? This will become 4 times 10 to the power negative 3. And then we subtract. No, where do I get the 4? This is 3 times 10 to the power 3, and then we'll take this to this side, so it's going to be minus 6 times 10 to the power 3, and then here we have 1,500 initial velocity of track B, and then we divide by 1,500, we divide by 1,500 both sides, and then we are left with that. So the initial velocity there is going to be negative 2 meter per second, and that means it's 2 meter per second. The negative means what? West. Remember, we chose east as positive, so we got the answer there. There are various ways of doing that, guys, but let's stick on that basic one. 4.4, it says, is the collision between the track elastic or inelastic? You cannot just assume, guys. Look at this, it's 5 marks. It says show how you arrive to an answer by means of calculation. So it's going to be calculation. So we're going to calculate the total moment, the total kinetic energy before, which is going to be half mv of initial velocity of A square plus the half mass of A times the initial velocity of B square, right? Now let's substitute. Do we have the mass of A? We have it's 2,000. It's 2,000, right? Do we have the velocity of A? No, we only have the momentum. So from the momentum and the mass, so we'll use the formula that says P is equal to mv. So we want the velocity, we'll divide by what? By m. So we're going to have V is equal to momentum over mass. So in the place of the velocity, we're going to say momentum. What is the initial momentum here? It's 6. We're going to say 6 times 10 to the power 3. We divide by mass. The mass of A, it's 2000. And then we square. That's going to be our velocity. And then half the mass here of B, it's 1500. And then the velocity of B, which is the initial velocity of B, it's the one that we just calculated in 4.3, which is its -2 square, right? So if we punch that in the calculator, we'll have the answer that is 12,000 joules. That's the total kinetic energy before. Let's do the total kinetic energy after. It's going to be half the mass. It's 2000 for A. And then the velocity after, and we do not have for A the velocity after. We're going to use the same thing. We're going to use the momentum of A, which is, this is the initial momentum. We're going to use the final momentum, which is 1. The final momentum is 1, so it's going to be momentum over mass, which is going to be 1 times 10 to the power 3. The mass is 2000, and then we square from this formula, guys. And then plus the mass of B, it's 1500, and then do we have the velocity after for B? So this is the initial momentum before for B, and then the momentum after is that one for B, and the momentum is 2, so we're going to say P over M, which is going to be, it's 2 times 10 to the power 3. That's the momentum after, and the mass is 1500, and then we square. And if you punch that in the calculator, you will get 1583,33 joules. If you look at this total momentum before and after, they're not the same. So we can say here the total momentum before is not equal to the total the total kinetic energy before is not equal to the total kinetic energy after. Therefore, the collision is inelastic. Guys, I hope you enjoyed the video and it makes sense to you. You can rewind the video and like the video, share with your friends. I hope it makes sense. Cheers. Bye.